Problem number 3, I went ahead and factored out that too, so we can see, we can just go right to it. We have amplitude is 3 this time. Period is 2 pi over 2, which is pi. And then the phase shift is pi over 6 radians to the right. Let's make that a better 6. Okay. And so we take our period, let's say we're going to move it to the right, so let's move this here. Our period is pi. Oh, let's move it over this way a little bit. There's pi. Okay. And then we section that off. We have pi over 2. We have pi over 4. Oops, I was thinking 6. And then we have 3 pi over 4. And we draw, oh, let's not forget the amplitude for this one is 3. So 1, 2, 3. 1, 2, 3. Okay, so we know the sine has these 4 key points. 1, 5. Did I say 4? 5 key points. Okay, 1, 2, 3, 4, 5. And we draw the sine graph. Same way, same shape as all the other sine graphs. And so, this should be kind of boringly easy. I don't know if that's a phrase that anyone ever uses. Boringly easy. Yeah, I mean, it's not the most exciting stuff, but at least if you're doing all the steps right, you're getting them right, and that's kind of nice. Okay, so there we go. There again, amplitude of 3, period of pi. Now the phase shift of pi over 6 radians to the right. Now we have to do a little work. 0 plus pi over 6, that's a pretty easy one. Pi over 6 is right there. Okay, so we've got 1 point on there. Now we have pi over 4 plus pi over 6. So what's that? Pi over 4 plus pi over 6. And we need a common denominator. This is where it gets really fun. So we have, common denominator would be 12, and so we have 3 pi over 12 plus 2 pi over 12. So we multiply the first fraction top and bottom by 3, the second fraction top and bottom by 2, and we get 3 plus 2 is 5, so we have 5 pi over 12. Okay, so there is a way you can kind of work the pattern here. So we have 5 pi over 12, 5 pi over 12. Really? Is that what we want? Pi over 6 radians to the right, pi over 4 plus, yeah, that's the way it goes. So we have 2 pi over 12, 3 pi over 12, and 5 pi over 12. It doesn't seem right. Why does that not seem right? Oh, that's why. Oh, no. That's right. Hold on a second. Let me think for a second. Okay. I was going to erase, because I know it messed me up here. It messed me up by putting the 5 pi over 12 so close to the pi over 4. But the 5 pi over 12 should be really right over here. 5 pi over 12. Okay. And then we have pi over 2 plus pi over 6. Pi over 2 plus pi over 6. And that is 3 pi over 6. So 4 pi over 6. 2 pi over 3. 2 pi over 3. And so let's put a couple points in here. Point there, point up there, a point down there. And then we have 3 pi over 4 plus pi over 6. And again, we're multiplying the top by 3, bottom by 3, top by 2, and bottom by 2. So we have 9 pi over 12 plus 2 pi over 12, and that would give us 9 plus 2 is 11. So we have 11 pi over 12, and that's right there, 11 pi over 12. And that's where we have a low point of -1. And then finally, pi plus pi over 6. Pi plus pi over 6 would be 6 pi over 6 plus, 6 pi over 6 plus pi over 6 is 7 pi over 6. So we have our last point, our x-intercept, 7 pi over 6 is right there. And now we go ahead and draw the graph of the original graph we were trying to draw in the first place. I didn't like that very much. Up here like this. Come down. Uh-oh. Did I mess up? No, good. I was thinking I was graphing the cosine and then had to do a lot of stuff over again. So there you go. The key x values, which these are kind of a pain. I agree. These are definitely a pain, but those are the ones that are important, and you've got to write those down if you have a problem like this. Okay? So that one took 5 minutes, so that's not a great thing here for me. So let's go ahead and move on. Maybe this next one won't take as long. Amplitude of 1, period of 2 pi over 2, so that's pi. Phase shift of pi over 2 radians to the left, so negative pi over 2. And we're going to go ahead and, I know I'm moving to the left, so I'm going to leave some space on the left. We have an amplitude of 1. Okay. Our period is pi, so we're going to put pi there. Divide our period into 4 equal sections, just like we've done. Okay. And then draw the sine graph. And the sine graph, we know that to look like this. Drawn it enough. Okay. I start getting a little sloppier. Okay. As we go, because I'm tired of drawing these graphs. But hey, I'm asking you guys to do it, so I might as well do it as well. Phase shift, negative pi over 2. So that's not so bad. Okay, so we can put our negative pi over 2 over here, and we're going to change all these values. Not all these values, actually, so we only need a couple values to change. And we're going to put the point there. 0, 0 goes to negative pi over 2, 0. Okay, pi over 4 here, goes there, there, and there. And we have our new graph. That wasn't so bad. There you go, there's number 4. And number 5, amplitude again of 1, period of 2 pi over pi, so the period is 2, and the phase shift of negative 1/2. So we do this. I know I had some students asking me about this one in class, and the question is, well, how do you do it? Well, you do it the exact same way that we've been doing all of them. I'm going to move to the left, so I'm going to leave some space on the left. My period is 2, remember? 2, so 2 goes down here. 2. Cut 2 in half, we get 1. Half of 1 is 1/2, and then halfway between 1 and 2 is 3/2. We draw the sine graph. Okay, oh, don't forget that the amplitude is 1. Okay, so the sine graph looks exactly the same as all the other sine graphs, it's just the period is 2. Okay, so, oh, no, it didn't go very well. Go right down here through 1, 0, and then go down here. And that wasn't great, but nevertheless, there's our sine of pi x. Okay, sine of pi x. Sine of pi x. Okay, now we're going to move this to the left 1/2. 1/2 unit. So we go negative 1/2, and we can see all the other x values are there. This guy goes there. Move it over, move it over, and move it over. And we draw our graph. So things are going smoothly now. Get it? Smoothly? Alright, number 6. Oh, we have a minus sign there. Oh no, what do we do? Amplitude is still 1 because the absolute value of negative 1 is 1. Amplitude will always be positive. Period is 2 pi over 2, which is pi. Phase shift is, negative pi over 4, so pi over 4 radians to the left. And the only thing that we really need to worry about here is making sure we don't graph the cosine of 2x. We're going to graph the negative cosine of 2x first. We put our period down there on the x-axis, divide our period in half, divide that interval in half, and then divide this interval in half. Right? Divide an interval in half. Divide it by 2. Divide it in half. Yeah, that's okay. Okay, and then the negative cosine, again the amplitude is 1, but negative cosine just reverses. Instead of starting at 0, 1, it starts at 0, negative 1. Okay, we go up like this. Now how do you know that? Well, you can plot some points. Negative cosine is a reflection of the cosine. Now remember, the cosine graph normally looks like this. Okay? And the green dotted line is a reflection about the x-axis of the green dotted graph. Okay, and so we could know how to do it that way. All right, well anyway, we're taking the negative cosine 2x and we are moving it to the left pi over 4 radians, and so that becomes pretty simple. We can go ahead and mark down our negative pi over 4 radians on our x-axis and then move our 0, negative 1 to negative pi over 4, negative 1. Okay, then we get it goes through 0, 0, goes through pi over 4, 1, goes through pi over 2, 0, and then 3 pi over 4, negative 1. So our graph looks like that. Alright, moving right along. Now I'm not really a big fan of that one. I want to come up like this one a little bit more. A little more curve to the bottom. Alright, you get the idea. So there's number 6. We're at the 11-minute mark. 3, 4, 5, 6 took 11 minutes. Alright. Okay, tangent. These are much more simple, actually. Don't have an amplitude for tangent or cotangent. The period, though, is just pi divided by the number in front of the x. And the phase shift for this one will be same thing, pi over 4 radians to the left. And the tangent, I always like to make sure, first of all, we want to graph the tangent of x. And that's sine x over cosine x. Okay. Two things are going to happen for the tangent. We're going to have vertical asymptotes, and we're going to have x-intercepts. Okay. The vertical asymptotes are going to occur where the cosine, where the denominator is equal to 0. And the cosine is equal to 0. Where? Well, when x is equal to pi over 2, 3 pi over 2, and so forth. Dot, dot, dot. And we have x-intercepts where the sine of x is equal to 0, and that's going to be at 0, pi, and so forth. Dot, dot. Okay? So that's all we need to mark down. And we're going to move it to the left, so let's save some room on the left. Remember, we have x-intercepts at 0, pi. So let's go ahead and section off our x-axis by first drawing the coordinates of the asymptotes. Okay, so we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, pi there. We have negative pi over 2 and negative pi. So we'll leave that. And like I said, the asymptotes, let's put this in green. Asymptotes right here where x is equal to pi over 2. Because think about it, when x is pi over 2, the tangent doesn't exist. When x is 3 pi over 2, the tangent doesn't exist. Now you don't need to do this many intervals or periods of the tangent function, but I just wanted to make sure I gave this to you. Now we already know how to graph the tangent function, by the way. We did that in the cosmic catalog. So our green graph here for the tangent, maybe those asymptotes should have been a different color. Okay, this is what the tangent graph looks like. Okay, that's the tangent of x, that green dotted graph of the tangent of x. But we're shifting it pi over 4 radians to the left. This becomes a little bit tedious here, and I think that I'd like to do these things a different way. But committed to this one, so maybe I'll do the next one differently. Moving this pi over 4 radians to the left, we've got pi over 4. Let's just do one period. Okay, pi over 4, that's going to have an asymptote, because the vertical asymptotes have to move to the left. 0, 0, an x-intercept moves to the left to negative pi over 4. That's an x-intercept. And then this vertical asymptote at negative pi over 2 moves to negative 3 pi over 4. So it's really helpful to know your unit circle. And I always have to double check. Did I get that right? Yeah. And then the new graph looks like this. Okay, that's over one period. And then we could do the same thing. Where would our other asymptote be? Between pi and 3 pi over 2 would be 5 pi over 4. Okay, another asymptote. And then an x-intercept would be 3 pi over 4. Okay, so there's two periods of this tangent function. And that is, in fact, the red graph is the graph of the tangent of x plus pi over 4.